Hello, am I audible? If am I audible, you can inform
Yes,
me by sending message in. Okay, Isha, Harsha, am I audible? Okay, dear student, we start. We start by taking some questions. Okay, today we will solve some problems. Very good problem I have selected today. Girls, you check. This is a question I have written on the screen. Okay. You please listen. In this question, a YouTube is given. This is the YouTube. Okay. This YouTube is like this. YouTube is given. It is said that this height is okay. Okay. This height is 20 centimeter. So this water column and all columns are there. So this is oil. So its height is 20 centimeter. Or this is the water column. This side. And its height is given 15 centimeter. In this question, we have to tell. In this question, we have to tell the density of oil. Its density. Density of oil we have to tell. So we can take this point. Okay, this point you take. This is A or this is point B. Okay. So pressure at point A will be equals to pressure at point B. Isn't it? So this height is 15. Okay. P equals to H rho G. H rho and G. But upside pressure is also a atmospheric pressure. So pressure at point A will be atmospheric pressure plus this. Pressure at point B will be what? P naught plus H height pressure is H. H means here this height is 20. H rho and G. This P naught cancel. This G and this G cancel. Okay. So in this question, density of oil is asked. So प्यारे बच्चों, this is 15. Density of water is given here. Okay. That is 10 to the power 3. Divide by, bring this 20 down. This will be density of oil. So 5 3 are 15, 5 4 are 20. Okay. So accordingly, 3 upon 4 into 10 to the power 3 equals to density of oil. This will be the answer. Can you solve it? Yes. What may be the answer? Can you solve it? You solve it.
So 750, sir. Third option.
7. Very nice. Very nice. So answer will be 750. Okay. After solving it, so density of oil will be 750 kilogram per meter cube. Okay. That's it. Okay. Let's go for the next question. The next question is on screen. Okay. Next question is on screen. You please try to solve and tell me the answer. Start this. You solve. You have time 2 minutes.
H2 by H1.
Very good, Pradhana. Very good, Harsha. Next. This is also a YouTube-based problem. Okay. This height is given h. But this height is given h2. So you are seeing at the same level, pressure will remain same. Okay. It is saying relative density of paraffin it is asking. So at this point, you take this point is x or you take this point is y. So pressure at point x will be equals to pressure at point y. So P naught plus H1 rho. So this is what? CD column is having paraffin. This is having paraffin. The density of paraffin. This is G. At point Y, P naught plus this is H2. Okay. P naught plus H2 rho. This AB is having water. This AB column, water. So density of water and G. This cancel. This cancel. It is asking relative density. So paraffin density, okay, upon water density. This is the paraffin density upon water or water density. You bring this like, okay, this will be H2 upon H1 because this is paraffin upon water density, or this will be H2 upon H1. So that's why we got the option A. Option A is the correct option. Very good. Very good, Madhumita. Okay. Now we are taking next problem. Okay. You please solve this problem. This is a little better problem. Please solve this. First you read this problem and then solve it. This is the same problem as I solved in the classroom. In this question, two solid uniform spheres are given, each of radius 5 centimeter. So two solids are there, each of radius 5 centimeter. So you take this first sphere. This is the another sphere. Okay, radius is given 5 centimeter. Okay, its radius and its radius. Both radius are 5 centimeter. Same. Totally immersed in the tank of a water. Totally immersed in the tank of a water. You take this is the water tank. Okay. This is the water tank. Next step will be what? Next it is saying Specific gravities are given. Specific gravities means relative densities. These are given. Okay. So I'm giving the name. This is the sphere 1 or this is the sphere 2. Specific gravities given. So you please keep in mind 0.5 for 1 or this for 2. Okay. Find the tension in the string. Both are connected by string also. So we have to find the tension in this. We have to find the tension in this. Contact force between the bottom of the tank. So contact force is there. So definitely, if it is talking about the contact force, so it means this is the ground. Bottom of tank. This is the bottom of tank. So bottom of tank, it means it will give normal reaction. Okay. Find the tension in the string and contact force. So this contact force also we have to find. These both things we have to find. Harsha, what will be the
Yes, sir.
approach? What will be the approach?
So for finding tension, we can use the first sphere, sir, because only three forces will be acting. It will be buoyance force, tension, and mg.
Yes.
So T plus mg is equal to the buoyance force because it is floating.
Yes,
So
yes.
tension will be equal to V density of fluid into G
Yes.
minus V density of solid into G. Now, if we
Yes.
take V density of fluid G as common, it will become 1 minus density of solid by density of fluid. Here they have given density of solid, that is relative density, specific gravity is 0.5, sir. So V density of fluid into 1 minus 0.5, it will become 0.5 into volume of the solid, density of the fluid into G.
Okay. Now you solve it and tell me the answer. Okay.
Yes. Sir, is it 2.6?
Madhumita, are you solving?
Yes, sir, I'm trying.
Okay, beta.
Sir, answer 2.6 Newton per meter.
2.6 Newton for what? For
Meter
tension?
square, sir.
For tension?
Yes, sir, tension.
Yes, 2.565.
Yes.
Very good. And for the reaction, it is also talking about the contact force. We have to find the contact force also. Have you solved it?
So 1 minute, sir, calculation alone.
Okay.
Sir, 7.85. Sir, normal force. Sir, you're muted, sir.
Normal force is not correct. It is coming 2.565 as the solution is in front of me.
Oh. Both normal and tension force, sir.
Yes. Let us check. Maybe the answer wrong. Let us check. Okay. Don't worry. So one thing is given in this question, uniform spheres are there. Two uniform sphere each of radius. So volume is same. This and its volume is same. So you take this is the, because its density is 2. Its density is 2. Its density is 0.5. These are relative densities. So definitely may be possible this is the heavier because this 2 sphere 2 is having more specific density. It means it is heavier. Okay, so this is heavier. That's why it is going down. So let us take first heavier. So on this heavier, you take this heavier. Okay. Number 2, this is heavier. So upthrust force downward will be mg, and this normal reaction is also given by the bottom. Okay. So upthrust is V rho z. V density you can write what? Density 2 into rho of water. Are you understanding? And G plus normal reaction equals to mass equals to density into volume. So density will be 2 into this. Okay. Into G. Okay. So this is the equation. But one more thing is also there. This tension we will also have to include. So upside this tension also is there. So this tension plus also. So we made the equation 1. We made this equation 1. Okay. Similarly for the lighter. So this is the lighter because its density is lesser, its density is more. For the lighter case will be what? This tension is downward on this. So tension or downward also its weight. Its weight will be what? Mass into mass equals to density. Density will be 0.5 density of water. Okay, this is Z. And upthrust force will also be there. Upthrust here also upthrust. So upthrust force will be V into density. Density is 0.5 into rho W into Z. So this will be the second. So प्यारे बच्चों, if you put the values, value of T here and value of T here, both are same. Okay. If you put this value of T in this, okay, put the value of T. So this will become what? So from this second equation, from this equation, T will be what? T will be 0.5 V rho WG minus 0.5 rho WG. Okay. So this will be the tension. Put this tension in equation. Put in equation first. When you will put this in equation first, so equation will become, I'm directly writing this normal plus 0.5 V rho G, rho of water, okay, equals to V rho G. Okay, so finally you will get this normal reaction will be, this normal reaction will become what? 0.5, okay, V rho G. Okay. On putting this value of T in 1, you will get this. Okay. So now you can make this another equation. Like you can say this is the equation 3. Okay. Informations are given. Density of water. Okay. Volume you can find 4 by 3 pi r cube. R is given here. 5 centimeter. Okay. So you can write this also like I think I should erase this. Something is there. From here it will be erased. No problem. Okay. So 0.5 Okay. Volume is 4 upon 3 pi r cube. R cube. R means 5 into 10 to the power minus 2 cube. Into G you can take 10. This density is remained. Density is water is 10 to the power 3. After solving this, you will get, after solving, I'm writing, you will get it 2.565. 2.565 Newton.
Yes, sir.
After solving that. Okay. But if you got this value n, okay, you can find the tension very easily. Okay. Otherwise, you can find the tension from the second also. Directly from the second. Okay. Find tension. Okay. Directly from second equation. Okay. Directly from second equation, you can find distance. Okay. Second equation. Second equation is this. Okay. Same you will get from here. This is 0.5. This is second equation. This is 0.5. Okay. This is V. This is also 0.5. Accordingly, you will also get. So directly from second equation, you will also find after the calculation 2.565 Newton. 565 Newton. Will you tell me who got this same 2.56 Newton after calculating it?
Sir, I got 2.6 Newton, sir, with round off.
Okay, approximately you are getting same.
Yes, sir. Correct. Yes, sir.
Then okay. So now last question we are taking. Okay, this is very nice question. Now you all tell me, will you solve it? Is there any problem in the concept?
No, sir.
Same type of problems I have taken in class. 2 problems yesterday I took in class. Is there any problem in this?
No, sir.
Okay, so I am giving you one more problem. You please check it and try to solve it. In this question, it is given a tube of length 50 centimeter. This is any tube. Okay. This is a tube. Tube of length. It is filled with incompressible liquid. So, प्यारे बच्चों, in this liquid is filled. Okay. This liquid is filled. It is saying this tube is rotated in horizontal plane about. Okay. About. It is rotated about one end with angular velocity omega. This is omega. With angular velocity is also given here. Angular velocity. I am taking general omega. Okay, don't worry. So if F be the force exerted, oh yes, प्यारे बच्चों, in this question it is saying if the F be the force exerted by liquid at the other end. So this is the other end. Okay. So this force is given here. So will you tell me how you will handle this situation? प्यारे बच्चों, this liquid, this length of the liquid, this length of the liquid, okay, on rotation, okay, more length of the liquid will provide more force because you know very well when it is rotated like this, so this water will go this side, okay, this side, but that water will create the pressure on this wall. Okay. So you go at x distance first. So you cut dx because every part will exert different force. You cut dx. Okay. You take this total length is L and total mass is M. So this dx length will have what mass? This dx length. This dx length will have the mass.
M dx by L, sir.
Yes, very good. This will have mass m upon L into dx. Okay. Or this is rotating. So pseudo force will be what? Centrifugal force will be there. At this
M R
place,
omega square.
centrifugal force. dF equals to m r. Okay. M r omega square. Am I correct? Say am or L.
Yes, sir.
Okay. So due to only this, so pressure here I found it. Due to this part, due to this part. Okay. I have to find the pressure due to the whole part. So प्यारे बच्चों, dm you know already what is dm. M upon L dx x omega square. This is dm. So integration will be what? This will be the integration. Okay. So you solve it. If you will solve it, so this total force will come what? This M and L constant. Okay. And this will be omega square is also constant. So this will be x dx. So F will become what? M upon L omega square. This is x square upon 2. But you integrate from this x equals to 0, x equals to L. Say am or L.
Sir, under
Okay.
root of L by M, sir.
Under root by
L by M.
let us check this F M upon L omega square limits are 0 to L. So this is L square upon 2. This L cancel. So F will become what? 1 by 2 M L omega square. So it is saying here, it is saying this F is the force exerted by liquid on other end. So here the force will be what? Due to this whole length. This is that force. So it is saying angular velocity. It is asking about angular velocity. So this angular velocity will be what? 2 F upon M into L. This is the under root. Okay. So in place of, so this is under root 2 upon M into L. This is under root F. प्यारे बच्चों, now you tell me one thing. Omega will be equals to what? So this 2 mass is given or not anywhere? Yes. This 250 gram is given. 250 gram means what? 250 gram divided by 1000. This is kilogram. Okay. Into L. Length is what? 50 centimeter. So 50 upon 100. Okay. 50 upon 100. I'm writing here. Okay.